Go ahead and try this problem and pause the video, and then when you're ready to see the solution, unpause. So if you remember from last semester, in order to solve something that looks like this, we would add the 35v to the left side of the equation. So now we have 7v squared plus 35v minus 42 equals 0. And our goal would be to factor this so that we can use the zero product property. Remember that the first step of factoring is to look for a GCF. So I can factor out the GCF of 7, and I'm left with v squared plus 5v minus 6 equals 0. Since I'm solving in this problem, I can go ahead and divide the 7 out. So then I'm left with v squared plus 5v minus 6 equals 0. And now I want to factor this. I can factor this into v plus 6, v minus 1, which gives me v plus 6 equals 0, v minus 1 equals 0, which means v equals negative 6 and v equals positive 1, or v equals positive 1. So those are our two answers. We applied the zero product property. The set of two numbers are multiplied to equal 0. We can set each of them equal to 0. So in this chapter, we're going to use that method, factoring the solving, and then another method to solve quadratic equations. So let's go through the steps that we just did for factor to solve, which is what we did in the warm-up. The first thing that we did was set the equation equal to 0. And then we factored. And remember that the first step for factoring is to look for a GCF. And then you can use one of the other methods, split the middle, difference of squares. Any of those will work. And then the last thing that we did was apply the zero product property. So to use the quadratic formula, our first step is going to be the same. Our first step will be set the equation equal to 0. We want to make sure that our equation is in standard form. And remember that standard form was ax squared plus bx plus c. And then the last step would be to use the quadratic formula, and the quadratic formula is this. Opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. So this is using those coefficients from standard form to solve and find what x is. So again, these are two different ways you can factor to solve, or you can use the quadratic formula. So let's use the quadratic formula on these two problems below. So for number 1, remember the first thing that we want to do is set it equal to 0. So I'm going to subtract 2 so that I get 2x squared minus x minus 15 equals 0. Some find it helpful to go ahead and identify what a, b, and c are. So if I just want to write out a is 2, b is negative 1, c is negative 15. That way I kind of have those ready to go. And now I want to plug into the quadratic formula. So x equals, remember that the first thing is opposite b, so that would be 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 15, all divided by 2 times 2. Notice that this 2 times 2, the 2a part, is underneath everything, so the entire numerator is being divided. So x equals 1 plus or minus the square root of negative 1 squared is 1. Negative 4 times positive 2 times negative 15 is going to give us 120 divided by 4. So then that would be x equals 1 plus or minus the square root of 121 divided by 4, which would be 1 plus or minus 11 divided by 4. Since 1 and 11 are like terms, you can add and subtract those. You should go ahead and do that. So we would say x equals 1 plus 11 divided by 4, and x equals 1 minus 11 divided by 4. 1 plus 11 would be 12, divided by 4 would give us 3. 1 minus 11 would be negative 10 divided by 4, which would be negative 5 halves. So our two answers here are 3 and negative 5 halves. We're not going to do the part about sketching the graph, but we will go ahead and talk about the type of roots. So since we got these two answers, 3 and negative 5 halves, we got 2 real roots. These are our 2 real roots. All right, let's look at number 2. So for number 2, again, I want to set it equal to 0. So I'm going to get 8a squared plus 6a plus 5 equals 0. Let's identify a, b, and c. A is 8, b is 6, c is 5. And now let's go ahead and use the quadratic formula. Let me try and divide this up. So x equals opposite b plus or minus the square root of 6 squared minus 4 times 8 times 5, all divided by 2 times 8. So that would be negative 6 plus or minus the square root of 36 minus 4 times 8 times 5 is 160 divided by 16. So that would be x equals negative 6 plus or minus the square root of negative 124 divided by 16. Off to the side, I'm going to break up negative 124. A perfect square that goes into that is negative 4 times the square root of 31. We learned last unit that the square root of negative 4 is 2i. So now I have x equals negative 6 plus or minus 2i times the square root of 31, all divided by 16. Since I can divide negative 6, 2, and 16 all by 2, I should do that. But I have to look for something that comes out of all 3 of them, since both of those numbers are being divided by 16. So then we should get a final answer of x equals negative 3 plus or minus I times the square root of 31 divided by 8. So that's our final answer. If I want to state the type of answer that is, that would be 2 imaginary roots, because it has an imaginary number. Each of those roots, one would be x equals negative 3 plus I root 31 divided by 8, so there's one, and the other one is negative 3 minus I root 31 divided by 8. So these are my 2 imaginary roots. So we also want to be able to tell what type of roots we'll have as soon as we see an equation or before we do the quadratic formula. So looking at the quadratic formula, let's determine which part tells us whether our answer will be real or imaginary, or which part determines that. And that would be this part right here, the part underneath the square root, b squared minus 4ac. So this part is called the determinant. It determines what type of answers you'll get. So let's fill in this below. So if b squared minus 4ac is less than 0, then that means we will get imaginary solutions. We also want to talk about how many of those we'll get. Since the plus or minus is there, we will get 2 imaginary solutions, just like we did in the example just before this. If b squared minus 4ac is greater than 0, then we will get 2 real solutions, like we did in number 1. If b squared minus 4ac is equal to 0, so that basically means that we're getting something like this, x equals negative b divided by 2a, because if I think about adding and subtracting 0, that's not going to change anything, so that just simplifies to negative b over 2a, then that would be 1 real solution because it does not have an imaginary component to it. So let's try this one. Find the discriminant and state the type of roots. Then use the quadratic formula to find these roots. So first thing I want to do is set it equal to 0. So I'm going to subtract 1. So I get 4x squared plus 4x minus 9 equals 0. And let's identify a, b, and c. A is 4, b is 4, c is negative 9. And let's find the discriminant first. So remember, the discriminant is b squared minus 4ac. So that would be 4 squared minus 4 times 4 times negative 9. So that would be 16 plus 144, which would be 160. Since 160 is positive or greater than 0, that means that we will have 2 real roots. So we found the discriminant, we have stated the type of roots, and now we want to use the quadratic formula to find those roots. Let's just rewrite the quadratic formula just so that we're making sure we're memorizing it. X equals opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. Notice that this 160 represents this b squared minus 4ac. So when I plug into my quadratic formula, I can say negative 4 plus or minus the square root of 160, all divided by 2 times 4. And that, finding the discriminant now has made my life a little bit easier. So now we have let's see, we need to break down the square root of 160. So let's do that over here. So the square root of 160, the perfect square inside of 160 is 16 times 10, so that would become 4 square root of 10. So now I'm going to say, instead of typing in the square root of 160, or I'm sorry, writing the square root of 160, that's 4 root 10 divided by 8. 4, 4, and 8 are all divisible by 4. So now I can say my final answer is negative 1 plus or minus the square root of 10 divided by 2. So this is a real root because it doesn't have an imaginary component, but the square root of 10 does make it an irrational number. Okay, the last problem on this page talks about a rectangle and its perimeter. So a rectangle has a perimeter of 100 centimeters. Find the greatest possible area for the rectangle. So let's draw a picture first. Here's my rectangle. I have a perimeter of 100. Let's call this the base and the height. And let's see if we can write an expression for the base and the height. So it would be 2b plus 2h equals 100. That's our expression for perimeter. And what I want to do is write one in terms of the other. And we've had this on a few different quizzes and tests. So let's solve for B. So then this would become 2b equals 100 minus 2h, and then b equals 50 minus h. So now I can say that this rectangle has sides h and 50 minus h. And if I want to think about the area, because it says to find the greatest possible area for the rectangle, I can write an expression, area equals base times height, as area equals h times 50 minus h. If I distribute that, that becomes 50h minus h squared, or negative h squared plus 50h. Something like this, clearly this is a quadratic because it has a square root, and since the leading coefficient is negative, that means it will open down. So let's figure out where the vertex of this quadratic is. So I'm using negative b divided by 2a. Negative 50 divided by negative 2 gives me a positive 25. So I know if I'm sketching my quadratic, the x part of my vertex is at 25. And then we can figure out where the y part is. So this would be negative 625 plus 1250, which would give us 625. So that means that, just doing a rough sketch, that means that the vertex of my parabola is at 25, 625. And since we said our parabola is going to open down, that means it looks something like this. So the height is representing, or the h is representing the different sides of the rectangle, and then what comes out, or the y value, is representing the area. So in this case, the greatest possible area would be 625 because that's the maximum value for this parabola.